Organized by Naveen, who is a key organizer in today's DevFest event. In that event, I learned so many things about AI and ML, and in fact, it is a turning point in my career because that event kickstarted my career in artificial intelligence and machine learning. And 4 years later, here I am. Today, I am working for Zoho Labs, where I am developing an AI future for various Zoho products, which will be used by more than 20 million users every month. So today we will be discussing about a Sentence-BERT, a model that built on top of Google's BERT model for providing efficient sentence embedding. And then we will be discussing about how transformer architecture and encoder models work. Then we will dive into Google's BERT model. Then we will see where a Sentence-BERT model can be used in tasks like text clustering, search, and classification. So by the end of the talk, you will have a clear understanding of how Sentence-BERT work and where you can use Sentence-BERT model in your business use cases. The information that I'm going to share today is purely based on my personal opinion and nothing is correlated with my employer. So let's begin. Now let us try to understand the transformer architecture with the help of our brain function. Our brain is split into two parts. One is the left side brain, another one is the right side brain. The left side brain is really good at logical tasks such as understanding the language rules, structure, and meaning. It is really good at analyzing and breaking things down and making sense of what is happening around us. So just like this, encoders in the transformer architecture reads the input, understand the context of each word in the given input, and it can able to understand what we are trying to convey in the given input. So encoders work just like however your left side brain processes the data logically and systematically. Now let's jump into the decoder stack. That is the right side brain. The right side brain is really good at creative tasks and imagination. In fact, it is a part of the brain that helps us to do creative tasks and imagine what might come next based on the given situation. So just like this, decoders in the transformer architecture predicts the next word based on the previous input and generate a whole new sentence out of it. Now, combining the encoder with decoder, working in hand to hand, this powerful combination makes the powerful architecture called transformer architecture. Now let us try to understand this with an example. Now we are going to pass an input. The input is translate this to English, Anevarkum Vanakkam. Now we will pass this input to transformer based large language model to understand how it will process the input and generate the translation for the given input. First, the encoder layer will read the entire input and understand the context of each word in the given input, and it will pack this information and it will pass this information to the decoder layer for generation. First, the decoder layer will take the understanding from the encoder layer and it will start generating the first word, hello. Now, to generate the second word, it will again take the understanding from the encoder layer, and this time it will also take the understanding from the previously generated word, and it will combine these two understanding and will generate the second word, everyone. So thus, the transformer-based large language model completes the output sequence. Now you may wonder how the encoder layer in the transformer architecture got the understanding of our human language. To understand this, let's imagine a situation where you are having a conversation with your friend, and for the first time, he says, I'm going to the temple. Let's imagine that you don't know the word temple here, so you don't know what it really means. So you start analyzing the meaning of the unknown word, temple here, with the help of other words in the same sentence. Since he says he goes to temple, so you guess that the word temple might be referred to some kind of places here. Now you ask him again, how often do you go there? He replies, my family and I go to temple every Friday for worship. In this sentence, you will learn two important things about the unknown word temple here. First thing, it is a place where people can go often, and it is a place where people go for worship, so it might be some kind of a religious place. So, even though you don't know the word here, you start analyzing the meaning of it using other words in the same sentence. So just like this, during the training period, we will provide a sentence to the encoder layer, and we will remove some random words from it, and we will ask the encoder layer to fill the blanks with the most suitable words. First, the encoder layer will read the entire input and understand the context of each word in the given input, and it will use this information to choose the most suitable words that can be filled in the blanks. So by doing it so repeatedly with more data, the encoder layer will learn the relationship between one word and other word in the same sentence. This training method is called masked language modeling. Now there is another training method called next sentence prediction. In this training method, we will provide two different sentences to the model, and we will ask whether the sentence 2 follows sentence 1. So in this method, the model will learn the relationship between sentence 2 and sentence 1, so it can get the depth of our human language. Now, as I said to you before, the output of the encoder layer will be sent to the decoder layer for generation. That output from the encoder layer is called embeddings. For those who don't know what embedding is, embeddings are array that contains numeric value, and each numeric value represents a particular feature of the word. The size of the array is called embedding size or embedding dimension. In simple terms, embeddings turns words into numbers in such a way that similar words can be grouped together and different words can be plotted on a graph further apart. Now let us try to understand this with an example. Now we are going to generate embedding for these words using two features. One is gender, another one is power. As we can see, the word king have so much power, so we will give him the highest value 50, and the gender is male, so we will give him another 50. So this is the embedding for the word king. Likewise, we will generate embedding for queen. The queen have less power as compared to the king, so we will give her 40, and the gender is female, so we will give her 20. Likewise, we will generate embedding for the remaining word, and let us plot the value on a graph. So as you can see, the word king and queen are placed near to each other because they have so much things common in power but differ in gender. In the same way, the word man and the word man and woman are placed near to each other because they have equal power but again differ in gender. So this graph tells us embedding helps the computer to learn the meaning of the word by looking at their relationship with other words. For instance, the difference between the man and woman is a change in gender, and the difference between the king and man is a change in power. So we can use embeddings to measure the similarities and dissimilarities of words using their features. Now there are so much models available in the internet, and one of them is Google's BERT model. It is an open source model, so anyone can use it. And the main advantage of using Google's BERT model is it will read the entire input at a time in both directions. For say, before Google's BERT model, it will be really difficult for older model to understand the context of the word because it have to read the entire input at a time, word by word from left to right. So it did not able to understand the context of the word efficiently. But models like Google's BERT model can understand the input efficiently because it can read the entire input word by word at a time from left to right and from right to left. Let's take an example. The man went to the bank to fish. Google's BERT model can understand that here the bank referred to the river bank, not the financial bank, because it can read the entire input at a time from both directions. So it can able to use the information from both directions, so it can understand that bank here is referred to the river bank, not the financial bank. And one more advantage of using Google's BERT model is it will give you embedding for all the words in the given sentence. For say, if you provide a sentence with four words, it will give you 4 embeddings for the given input. Well, Google's BERT model is built for word embeddings. Then what is good for sentence embedding? This is where Sentence-BERT model comes into the picture. To understand how Sentence-BERT model solves the issue in Google's BERT model, we need to understand how Sentence-BERT model is trained in the first place. So let's imagine, so we are going to give 2 different sentences to the Google's BERT model. These sentences have to be in similar meaning, but they can be in they can be in same language or different language. First, we will pass this input to the Google's BERT model. Google's BERT model will give you word embeddings. Then we will pass these word embeddings to the pooling layer. Pooling layer is nothing but the layer that converts a multiple array into single array. There are 3 types of pooling layer. One is average pooling layer that will calculate average of all the given array and will give you the final result. Another one is a minimum pooling layer that will choose the minimum value from the array and will construct the final vector. Another one is maximum that will choose the maximum value from the array and will give you the final vector. The output from this pooling layer is called sentence embedding. We will pass this sentence embedding to the cosine similarity function. Cosine similarity function is nothing but that will help us to calculate distance between 2 vectors on a graph. So since we provide the sentence with similar meaning, the output of the cosine similarity has to be 1 or close to 1. So this is how Sentence-BERT model is being trained. So this is how Sentence-BERT model is trained to generate a sentence embedding efficiently. Now there are so many models available in the Sentence-BERT website. So you can choose your model based on the accuracy, performance, and use cases. So each Sentence-BERT model have a different parameter and a different training data. So you pick your model based on the accuracy, performance, and use case. Now this is a sample code for using Sentence-BERT model in Python. First you have to install sentence transformer Python module. Then you can specify the model name. Then you have your input here. Then you pass the input to the Sentence-BERT model. Then you will get the sentence embedding. Then on top of it you can use any mathematical distance function to measure the similarities between them. So there are so many use cases for using Sentence-BERT model. Now we are going to walk through few of them. Now let's start with text classification and sentiment analysis. As we all know, text classification means categorizing the text into predefined categories, and sentiment analysis means predicting the emotion in the given input. Let's take an example that you are building an application that will evaluate the customer's experience. So you got a feedback from your customer saying that, I'm so much satisfied with the resolution, thanks for the service, keep it up. Now you will pass this sentence to the Sentence-BERT model. It will give you a sentence embedding. You can use this sentence embedding to measure to calculate the emotion in the given input. So if more customers are happy, it means success for your business. If not, the business can address it at the earliest. Then co-reference resolution. Let's imagine that you are building an application like a search engine, and you allow your user to put a query like, show me pictures of Dr. APJ Abdul Kalam and when he was born. In the second sentence, you mention E, not his name. But Sentence-BERT can understand that E referred to Dr. APJ Abdul Kalam from the first sentence. So it will give you the efficient sentence embedding for the whole input. So you can use this sentence embedding to query your database, and you will get the result. You can show this result to the user. Now this is our final use case, text clustering. Let's imagine that you have a bunch of documents or comments or any text or data. Now you are asked to group these documents based on their similarities. So you can use Sentence-BERT model here to generate a sentence embedding for the given input. Then you can use any mathematical distance function to group the vectors based on the similarities. Then here we go, you will get the final group the vector. So thanks for the opportunity. With this we came to the end of the talk. So if you want to connect with me, you can scan this QR code, and thanks again for the opportunity.